Hello everybody, welcome to Introduction to C#, or Application Development in C#. This is the very first lecture that actually has sort of course material in it, and what we're going to do is really talk through what C# is, what the .NET framework is around the language, and kind of give you a high-level overview of Visual Studio, which we'll start installing in the next couple videos. So first of all, what is C# to begin with? C# is a high-level multi-purpose language. It was created by Microsoft near or around the year 2000. And basically, you can do anything with C# that you could do with C or C++ or Java or any of these other sort of high-level languages, many of which we have courses on in the department. So I put this in here to indicate that you can do really whatever you want to with C#, but as we go through the course, we're going to obviously run into some things that C# is not super great about, and we're actually going to discuss the very largest of those at the end of this lecture. But if you so choose, you can actually use C# for basically anything you want to build. So exactly like Java, it runs inside of a virtual environment. What this means is that you don't take your source code and then compile it into machine code directly, like you do with C or C++. What's going to happen is the compiler is going to compile it into an intermediate language. That intermediate language is then going to be translated and run on the machine in a virtual environment that allows for sort of cross-platform development. But unlike the Java virtual environment that really is intended for cross-platform support, the intermediate language and the virtual machine that runs C# is really used to provide cross-language support. So while you can run C# code that's been compiled on a Mac that has .NET Framework installed, there are tons and tons and tons of caveats that we'll go over throughout the course. However, if you are trying to compile F# and VB.NET and C# and pick your favorite compiled .NET language, if you look at the intermediate code that's generated, it's virtually the same if you've sort of compiled the same code or the same program into the intermediate language, regardless of whatever high-level language you started with. So while the Java virtual machine really is intended to support cross-platform development, the .NET runtime is really to allow you to use multiple high-level languages that all compile to virtually the same intermediate code that's run on the machine. So just some kind of definition stuff. The virtual environment that is used by the .NET Framework is called the Common Language Runtime. So the CLR, it runs intermediate code that is created from whatever .NET language you want to write in using the Common Language infrastructure. So as long as the language that you are trying to compile adheres to this infrastructure, then the CLR will be able to run that language when it's compiled. So all of the CLI compliant languages compile to what's called the Common Intermediate Language, or CIL. The most common of these is obviously C#, but you could also look at things like VB.NET and F#. There are a host of other languages that are basically derivatives of other common high-level languages. So at one point in days of yore, there was a J# or a Java version that would run inside of the same virtual environment. There was IronPython, that was a Python version, or a version of Python that had access to all of the .NET libraries. There are many, many, many languages that do kind of very specific things and emulate other languages that all adhere to the common language infrastructure and can be compiled and run on the same virtual machine. So the way that all of this kind of works is you go into the IDE or potentially a text editor, which we'll talk about in a moment, and you type some C# source code, whatever. That is then passed to a compiler called Roslyn, And that generates some intermediate language in the CIL format. That CIL format language, you can think of it like bytecode from Java, can then be run on the CLR on whatever machine has the .NET runtime installed on it. And so then at the end of the day, what's happening is you have an executable, you have some program that is actually running on a server or on a client machine, whatever. And it doesn't really matter that it was in C# or if it was in VB.NET or F#. It's all really the same because it's running the CIL version of it in this common language runtime virtual machine. So just a quick comparison between C# and some other languages you might be more familiar with. So syntactically, C# is virtually the same as Java. So you have things like dot syntax, all of the ideas of how classes can be nested inside of files. All of that is very, very similar, if not exactly the same. And it is drastically different from something like C or C++, even though it is named C#. So that is a little bit of a misnomer. It's much more similar to Java than either C or C++. So the nice thing about C#, and really the nice thing about any of the .NET languages, is that library linking is extremely straightforward. So basically all you need is a DLL that's compiled to a compatible version of the .NET framework. You can drop it into your project, you add a reference, and you're done. And that's really it. There are very few barriers to using libraries, and a lot of it is managed by NuGet within the IDE. So it's very, very, very easy to extend your own libraries to larger applications, or to use very, very popular libraries in whatever application you're trying to build. So there's also a huge stack of .NET libraries that are virtually automatically linked by Visual Studio. There's this global assembly cache that exists inside of Windows, and that global assembly cache contains tons and tons and tons of libraries that help you do things like string manipulation, things like date parsing and date differences, all sorts of things that you can imagine you wouldn't necessarily want to recreate the wheel over time and time again. Basically, there's already a library for that, and most of the time that library is already included in the global assembly cache, so you don't have to really dig around too much for it. And so it is possible to code C# without Visual Studio or without another IDE. But in the case of this course, it's not a super great idea, and we'll kind of go through why that's the case. So first of all, Visual Studio is the kind of preferred de facto IDE for development of C#, and the community version of Visual Studio is free. And you can actually code C# in Visual Studio Code, which is nice for sharing if you have a group project or something like that. But what we're going to look at through the course is a lot of different templates of solutions. We're going to look at building mobile apps. We're going to look at building web services. We're going to look at building client-side applications with UI and without UI. Each of those things has a templated solution that you can effectively inherit from the internet to get started, so you don't have to rebuild everything from scratch every time. My experience with VS Code is that you can do the same thing, but in the previous iteration of this course, people found it very, very difficult to do so. Particularly around web services, when we start creating those, there were significant issues with A, trying to get the template set up correctly, and B, trying to get it to actually run from VS Code. If you want to go through the kind of heartache of doing that on your own, it's a great learning experience. I just sort of strongly recommend using the community version just to make your life a little bit easier through the course, because this is kind of a compressed semester. The other nice thing is it's super easy to install. So if you go to this URL, at the very top, there's a download link. It will detect what platform you're using, and so it should redirect you to the correct download. And that is just sort of it. You install it exactly the same way that you would install any other application on your platform, be it Windows or Mac. And from there, the weirdness of the IDE takes hold. So installing it isn't necessarily the problem. Trying to use it to generate a new project and understand what all of the bells and whistles mean, that's a whole different story, and we're going to have a whole different series of videos about that. So the most commonly asked question about C# on the first day of fall 2019 when we started this class was, is it possible for me to go into linprog and build C# applications without the IDE? It is possible if we were to install the compiler on linprog, which has not been done yet. You could technically just open up Notepad++ or Notepad or whatever your favorite text editor is, type a bunch of C# and then sort it out. Basically, the way that works is you would have to invoke the compiler and the linker at the command line, but that requires a thing called msbuild, and that is a non-trivial task to do. And in the regular length semesters, we kind of spend a little bit of time talking about msbuild. In the summer semesters, we probably won't end up having enough time to go over that in too much detail. So the follow-up question, and what I think most people mean when they ask, is it possible, is it easy to build C# applications without the IDE? And the answer to that question is absolutely it is not. The most straightforward way of doing this is to build a series of configuration files that are read by an open source application called msbuild, which then goes through all of those configuration files and then effectively builds up the tool chain that then converts your source code into the appropriate type of executable or the appropriate type of DLL. This is a really cool feature of the .NET framework and kind of the environment in general, but from the perspective of a student trying to get through a C# class in an abbreviated 10-week semester, it's more heartache than it is cool. So what I would suggest doing is using the IDE for the course, and then if you are very interested in kind of automating DevOps or doing things in a different way, at least the course will give you all of the basics that you need in order to make that a little bit less of a trudge. So Visual Studio itself is an integrated development environment, or IDE, that was specifically created to support the .NET and Microsoft ecosystem. So Microsoft built this thing, they maintain it, they are constantly updating it. There's a new version out maybe every other year at this point. And while it is very, very, very stable, it also contains a just hilarious number of features. And that huge feature set is probably the reason why most people find it kind of obnoxious. Very recently, maybe as of the beginning of last year, maybe the end of 2018, they added full support for the entire DevOps platform inside of Azure. Which means that you can do all of your application lifecycle management within the Visual Studio tool without actually ever leaving it. So you can build a web service in C# and then deploy it to a brand new endpoint in the cloud without ever having to go to PowerShell or ever having to go to Azure portal if you so desire. So there are other versions of IDEs that work for C#. JetBrains has one, and specifically, these things are kind of okay, but again, Visual Studio Community is entirely fully featured. It's entirely free as long as you don't surpass the maximum number of developers, which currently is 4. On a pay-to-use project. So if you and 4 of your friends are building an application in C# in Visual Studio that's making money, you would then need a license to use Visual Studio to create that product or maintain that product. Until that point, it's free, sort of for educational use. So one of the drawbacks to this is because of the Azure integration and because of all of these different features that are shoehorned into Visual Studio, you have to have a Microsoft account to log in to your copy of Visual Studio, even though it's free. So as a student at FSU, you have access to, I think it's $100 of credit in Microsoft Azure. So if you sign in to Microsoft with your FSU login, it should just sort of kind of work. And so you shouldn't have to set up a Microsoft account if you don't want to. You should be able to use your FSU credentials to get into the system. So the unfortunate thing about this is that it's made setup a little bit harder than it once was. So you can't necessarily just download, double click, install, and run with it. You do have to make sure that you're logging in with your FSU account, or you're logging in with whatever Microsoft account you've been using to post on forums or whatever. There is the infamous is this an IT work-related email or a personal email or whatever? If you get that dialog box and you're trying to log in as an FSU student, you should choose the first option, which is my IT company or school set up this account for me, something like that. In the next video, we're going to go through the whole thing. So there are going to be two different videos, one for doing it on Windows, one for doing it on Mac. And basically the intent of those videos is to show you that it's very easy to navigate and get the install files, and then to walk you through what some of the very first menus and stuff like that looks like, and to look at what the debugger looks like, because debugging inside of Visual Studio is actually quite nice. It's very similar to sort of the Eclipse feel if you've used Eclipse for Java. So before we move on to that, though, what I want to do is spend just a little bit of time talking about the idea of solutions and projects, and all of these kind of weird buzzwords that you're going to hear, particularly in the beginning part of the semester when we're talking about C#, the language, more than sort of architecture using C#. In what I'm loosely referring to as Microsoft land, there is an abstract hierarchy of these ideas that make up a program or make up a product. And all of this machinery around what is a solution and what is a product or a project and what is a library, et cetera, is really, really frustrating. And it's particularly frustrating if you are used to using something like GCC and Vim to just sort of do your job and get out of it. There's not a lot of overhead. With C# and with .NET Framework, there is a significant amount of overhead that you have to kind of trudge through in order to get to the nitty-gritty first. So my first kind of advice to people that are just now picking up .NET and C# is that you basically just need to embrace the machinery. There are very few things in the Microsoft ecosystem that are lightweight. Even if they say that they're lightweight right there in the name, typically it's not lightweight regardless. And at the end of the day, what's going to happen is all of this machinery is going to eventually do exactly what you tell it to do. But for the beginning couple of weeks of the semester, it's going to be really frustrating because you're not going to necessarily understand what all of the words mean, and you're certainly not going to understand what all of the exceptions or the errors mean. And you kind of have to accept the fact that I've been working in this environment for nearly 15 years, and I always find a new absurd word that I don't have a clue what it means, and you kind of just have to struggle through it. So what I told the last class and what I told people that I'm trying to train in industry is that you can basically think of the Microsoft toolchain around C# specifically as this giant mechanism that is completely alien, and you don't necessarily have to understand all of it in order to do your job well. But the more you play with it and the more that you sort of go through issues one at a time, you'll eventually find yourself being Mickey Mouse in Fantasia, and you just sort of like make all of the brooms do the sweeping and all the mops do the mopping, and you'll kind of pick it up as you go along. So this is the part that I want to go through first, because if you are not familiar with creating a solution inside of Visual Studio, it doesn't actually matter if it's on a Mac or if it's on a Windows machine. You're going to create a project and you're going to be absolutely shocked by the complexity of the stuff that has been generated just by clicking Create New Project. So this is a sample project. It's quite large. It has a whole bunch of different libraries and a whole bunch of different service layers and all sorts of stuff. But this is basically what a standard kind of project directory looks like for a C# project. You see that there are a whole bunch of different files inside of here. Most of them are inside of directories. Each of these directories is what is referred to as a quote project. So each of those things could be thought of as a project inside of Eclipse, for example, and they're all grouped inside of this solution called Xbot. So the solution itself has this .sln file. And so if you go in and you try to edit that .sln file in an XML editor, what you'll find, or a text editor, what you'll find is it's all XML. It's just this huge configuration file that tells you where all of the source code files are in each of these directories, which ones are dependent on each other, and where all of the output should be put once this whole solution has been compiled. All of these directories down here, these are all projects inside of the solution. Each one of these can be compiled on its own, and typically they represent a DLL that is then referenced by the solution that you're trying to create. Then you have these, inside of each of those directories, you have these .cs proj files. So .csproj stands for .c# project, and what these things do is they act as XML configuration files for each of the projects inside of the larger solution. So if you look in that solution file, the solution file will point to each of these configuration files. These configuration files then tell the compiler how each of these subdirectories actually work. How to link all of this code together at compile time. Two of the most important of the directories that exist inside of any of the projects are bin and obj. Bin is where all of the output of the compilation goes by default. Obj is a sort of internal temporary storage place where temp files get created during compilation. If you go into any of the directories inside of a project, what you should see in there are .cs or .c# files. Each of these is just a source code file. So if you wanted to create one of these things from a text editor, these are the files you would actually be editing inside of the text editor. And all of those other directories and all of those configuration files and all of the madness, that's the stuff that you'd actually have to manually create, which is not necessarily the easiest thing in the world to do. So in general, when somebody creates a C# project for the very first time, even though it's blank, it has a tremendous number of files, and they think to themselves, good Lord, what did I just do? And so this brings us to the very first kind of downside of C# and the .NET environment in general. C# projects themselves, the source code, the metadata files, all of that, they're extremely verbose. They have tons of files. Not unlike Java, that has a tremendous number of files for a very large sort of at-scale production program. The good news is that these things zip very, very nicely because everything outside of that temporary file or temporary directory and outside of the executables themselves tend to be pretty small text files. So if you delete the obj and the bin directories, which can be regenerated at compile time, you can pretty often zip up the rest of the solution, including all of the projects, into a fairly small zip file. So one of the things that people have a problem with at the organizational scale, so really software organizations that are trying to figure out if C# will actually allow them to do what they want to do, is that C# has a pretty bad rap in terms of general performance, things like that. If you look at a CIS file and that file is super large, just think to yourself that that is going to generate a bunch of code that potentially is going to also be gigantic and have to be stored in RAM somewhere on the machine that's actually trying to run the program. So in the situation where you're trying to zip up your solution, the solution zip file is still gigantic. A lot of the times this is because you have created this monolithic, gigantic CS file that itself is not super compressible. So if you have a solution that has tremendously huge CS files, typically that's an indication that you have some sort of architectural problem, some architectural debt somewhere, where you have maybe multiple concerns in the same CS file. You have way too much code centralized in one place. This is kind of a red flag in general, in the general idea of software architecture. So if you find yourself with gigantic files themselves, that isn't necessarily a problem with the framework and the environment. That could potentially be a problem with the way that you've actually organized the code. So even though C# has this kind of black eye in industry around performance, some of the performance is not necessarily directly related to the language. It's related to how the language is used. So potentially you could put an infinite number of projects inside of a single solution. So you could have hundreds and hundreds and hundreds of projects as long as the path to the source code files themselves are within the operating system's maximum directory length. However, the larger the solution gets, the longer it will take Visual Studio to load it. So I was working on a project with a whole bunch of different solutions in it. There's maybe 30 or 40 projects, maybe 2 or 3 million lines of code. If you try to load that solution in Visual Studio, it could take maybe 10 minutes to do so if your machine wasn't super great or if your machine was trying to do something else. So even from a software engineering sort of teamwork, sharing kind of idea, you kind of need to be cognizant of how you're trying to split up your solution files so that people aren't spending a lot of valuable time just kind of waiting around, waiting for the Visual Studio solution to load. You can always split them into smaller solutions and then reference one solution in the other. Yeah, and so like I said, I worked at a company a couple years ago. The largest solution there took about 25, maybe a half hour to load. And that is not a great situation because you don't necessarily want to be in a situation where you come in at 9 o'clock and you can't do anything until 9:30 because the code base that you're working on is so large that Visual Studio takes a long time to load. So just a really quick note about metadata files, what they are, what they do. The .sln files, what they provide is a manifest of all of the build dependencies at the solution level. So if you have a whole bunch of projects that are all interdependent, it will provide the order in which those projects have to be compiled. But it also gives compile time information about configuration. So if you want to compile to an x86 architecture versus an x64 versus a whatever is available kind of build, you can also specify that inside of the solution file. It also allows you to specify what version of the .NET framework should be available in order for the program to run, and sort of things like that. So that's a very high-level solution level configuration. The .cs proj files give you a very verbose markup of all of the settings, all the dependencies, all the post-build actions, all of that for each of the projects inside of the solution. So this basically allows you to specify when a specific project is to be built, how it should be built, what should happen after it's built, etc., etc. So these two things together basically give you this gigantic customizable tool chain that you can actually use to automate all of your application lifecycle management that you want. You can do crazy stuff like generate a whole stack of code, which we'll do the last week of the class. You can trigger code generation based on contextual flags. You can institute Git dependencies inside of your build chain, whatever you want to do. And the depth of all of that automation is something that we will basically just scratch the surface of near the end of the class. So suffice it to say, if you are very interested in DevOps, if you're very interested in lifecycle management automation, these metadata files are sort of your friend, and you can do whatever you want to with them if you get good enough at PowerShell. So a quick note about the next steps. So this week, what we're really focused on is trying to make sure that everybody in the course has an environment that actually works. So the next couple of videos are going to walk through the download and walk through creating a new project inside of Visual Studio. I'm going to take you through the really kind of high level features of the IDE. And then that's going to be done for both Windows and for Mac. So if you have access to Windows, you have access to Mac, you should be completely fine. If you're trying to run on Linux, there is supposedly a way to do that, largely through VS Code. I have never done it myself. I'm happy to try to help you learn, but hopefully everybody has access to Windows and or Mac, and so everything will be kind of okay. So you obviously do not have to watch the video for the operating system that you don't have. If you want to, that's entirely between you and whoever manages your time. But please do watch the video for whatever platform you're using. I'm going to try to go through all of the kind of gotchas in those videos for each platform so that we can kind of minimize the confusion of this startup period. So after those videos, there's going to be kind of a code along video where you can walk through with me the creation of a very simple 5-function calculator. And if you cannot get through that code along by the end of the week, I highly suggest that you email me at crmills@fsu.edu, and I'm happy to help you work through any kind of weird issues that you're having with your specific machine. If you make it through week 2 and you still don't have a functioning machine, your life is going to get exponentially harder as we start getting programming assignments and start working through each of the units. So it's really important that everybody has a functioning environment kind of by the end of the week, or at least by the beginning of next week. So with that, that is everything. I hope that you found this mildly interesting, but it is certain to get more interesting as we sort of get into coding and actually setting up projects. So thank you very much for your attention, and I hope to see you next time.